In this section, we're going to be talking about slope in a couple other ways. So if you would open your Intro to IM2 flipbook and turn to section number 3. We're going to be filling out the bottom flap of section number 3. There's a couple things I already have pre-filled out here. These titles, if you want to fill those in now. This section is titled Slope with 2 points known. And then on the right side we have finding slope when you're given an equation. We'll cover that one in a moment. And if you want to go ahead and just write the slope formula here, slope formula is the difference between the y values, or y sub 2 minus y sub 1, over the difference between the x values, or x sub 2 minus x sub 1. So the question, what is the slope of the line which contains the points -3, -4, and 7, 1? What is the slope of this line? And we can figure this out by using the slope formula. Let's do what we always should do in this case when we're going to plug values into a formula. Let's label our values so we know where to plug them in. The -3 is the value of the x coordinate, so I'm going to put an x here, and the 7 is also an x value. Let's label one of these x sub 1, and we'll label this one x sub 2. And then we have the y coordinates. -4 is the y value on this coordinate. I'll make that y sub 1, and then this y value will make y sub 2. Remember again, whatever sub number you use here, sub letter you use, these need to match because it tells you that those two coordinates are from the same point on the graph, and these two values of x and y are from the same coordinate, 7, -1. So now we know that slope is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. All I have to do is plug in the values. We know it's going to be a fraction. Slope is a fraction. Y sub 2 is 1. Now remember, the minus sign is part of the equation. So put that in here first, and now take a look at what y sub 1 is. In this case, y sub 1 is -4. So now we put -4. X sub 2 is 7. Again, the minus sign in our equation, it's part of our equation. Both of these have minus signs in them. So we're going to put minus. And now take a look at x sub 1. X sub 1 is -3. So there is our slope. Let's go ahead and figure out the math. Y minus -4 is the same as y plus 4. The first negative cancels out the second negative, and it ends up becoming an addition problem. So 1 plus 4 is 5. 7 minus -3, that's 7 plus 3, and that's 10. And we have a slope of 5 over 10, and I will tell you that is a correct answer, but it's not your final answer, because whenever you end up getting an answer like this as a fraction, if it can be simplified, you need to simplify it. And there's two ways you could do this. One is to simplify the fraction. Number two is to do 5 divided by 10 in your calculator, and you're going to get 0.5. But I don't want you to do that with slope. I want you to leave slope as a fraction. So 5 over 10, I can see that both of these numbers are divisible by 5. I can divide 5 by 5. I can divide 10 by 5. 5 divided by 5 is 1. Hold on a second while my computer catches up with me. 5 divided by 5 is 1. 10 divided by 5 is 2. And our final slope is 1 over 2, or a slope of 1/2. Okay, take a look at the second part of this, the top part of this flap. Slope with an equation. Now you have done this before in Algebra 1 and probably in previous math classes. The equation of a line can be written a number of different ways. One of the most common ways is to write it as y equals mx plus b. This is called the slope-intercept form. So y equals mx plus b is an equation in slope-intercept form. Why do we call it that? Because this equation tells us the slope and tells us the y-intercept. M, which is the coefficient in front of the x value, that is the slope, and the value of b is the y-intercept, or another way to put it is, it's where the line crosses the y-axis. So based on this form, the slope-intercept form, the kind of question you may see is, like this one here. What is the slope of the line? And this should actually have a y here. I'm going to fix this. I'm not sure if your flipbook will have the same problem. But let's go ahead and correct this right now. This should say, what is the slope of the line? Y equals negative 1/2 x plus 4. Negative 1/2 of x plus 4. We'll take a look at this. We have y equals mx plus b. The m value is the value that's right in front of the x value right here. And that is your slope. The 4 is the b value, which is where the line crosses the y-axis. So the slope of this line is actually easy to find. It's right here. And you can actually write this as the slope is negative 1/2. You could also have written this as negative 1/2. You could also have written this as 1/-2. Remember from previous discussions of slope, that minus sign can be out front or on top or on bottom. As long as it's in one of those three places, the fraction is the same. And if you think about this, negative slope, that means it's actually facing this direction on a graph. It's going from high to low as you go from left to right. It's a negative slope. And I'll put a little note here. Let's put a little notation. The line is decreasing. In fact, let's just do it like this. The line is going down. Make a little note so you guys remember that's a negative slope. Okay, so now we'll turn our discussion to the bottom half of this flap. We've already just completed the slope with 2 points known and slope with an equation. So now we'll do slope of parallel lines and perpendicular lines. Take a look at the titles. I've filled those in for you. Slopes of parallel lines. And this symbol right here, I'll just circle it temporarily and show you. This double vertical line is the geometric symbol for parallel. So I put that on there so you guys will remember that. And then the heading over here is slopes of perpendicular lines, and this is the geometric symbol for perpendicular lines. Looks like an upside down T. If you think about it, it basically is showing the base of something and then a line that's making a 90-degree angle with that base. So those two lines are perpendicular. Okay, so here's what we have to know about slopes. If you have two lines that are parallel to each other, and that means they're never going to touch, that means they have to have the same slope. So parallel lines have the same slope. So the kind of question you'll see regarding this is, here's a question. What is the equation of a parallel line that is 5 units above the equation y equals 3x plus 5? Well, remember, this is an equation of a line. Remember, y equals mx plus b. This 3 is the slope. Okay? This 5 is the y-intercept, where it crosses the y-axis. So a couple things we know. If the equation we're going to write is parallel to this line, then the slope has to be the same. That means our equation has to be y equals 3x, because our slope must be the same. Parallel lines have the same slope. The slope here is 3. The slope of our new equation has to be 3. Now the question is, how do we get a line that is 5 units above? Well, let's think about this. I'll scroll this a little bit and show you. If I have a coordinate grid, and I'm just going to go ahead and plot a line on there, and let's say that this line crosses the y-axis at -1, and I want the line to be 5 units above that. All I do is count 1, 2, 3, 4, 5, and that point right there is now going to be at y equals 4. Think about it. From -1 to 4, that's 5 units that we moved. The slope is going to be exactly the same. The slope will be exactly the same. So in this case, our y-intercept is 5. All we have to do is add 5 to our y-intercept. So instead of being y-intercept of 5, we have the y-intercept as 5 plus 5, which is 10. And here is our new equation. Easy peasy. Y equals 3x plus 10. And in parentheses, let's go ahead and put on there. Okay, add 5 to the y-intercept. The y-intercept. I just abbreviate that as y-int, so it makes a little less writing here. Add 5 to the y-intercept. The slope does not change because the line is parallel. Now let's take a look at the next section, the slope of perpendicular lines. The slopes of perpendicular lines are opposite reciprocals. They are no longer the same. Perpendicular lines, if we had those graphed, they're going to meet at a right angle. So if I had an existing line right here, there's my existing line. If I was going to make a line that was perpendicular to that, it's going to have a slope so that where it crosses this existing red line, it's a right angle. And we accomplish that by having opposite reciprocal slopes. Here's a good example. If the slope of your initial line is a over b, then the slope of a perpendicular line to that line is negative b over a. Let's take a look at what changed. Reciprocal means to flip the fraction around. A over b becomes b over a. Opposite means change the sign of the slope. It was positive here, it becomes negative here. So when you are finding the slope of a perpendicular line to an existing line, you take the original slope, flip it over so it's the reciprocal, and then change the sign. Let's take a look at our example. What is an equation of a line which is perpendicular to y equals negative 3x plus 5? Well, we know that our existing slope, or our initial slope, is negative 3. That's our slope. Okay, if our slope is negative 3, then think about our perpendicular line slope. Negative 3 is the same as negative 3 over 1. I think you agree with that. Any fraction, you can put a 1 in the denominator. It doesn't change the number. 2 is the same as 2 over 1. 7 is the same as 7 over 1. So negative 3 is the same as negative 3 over 1. So if our original slope is negative 3 over 1, then our new slope for our perpendicular line, we're going to reciprocal, so it's going to become 1 over 3, and then we're going to flip the sign. It was negative before, it's positive now. So the sign changes. Flip the sign and flip the fraction. So our new equation is going to be something like this. Y equals 1 over 3x. And it doesn't tell us that we have to move the line up or down. So let's just go ahead and leave the y-intercept exactly the same. Y equals 1/3 x plus 5. And we'll put a little notation here. All we did was we created opposite reciprocal slope. And that's all there is to it. That line, if you graph that line, it will meet this existing line, the original line, at a 90-degree angle.